So we are going to begin our day talking about these 4 vocabulary words. Okay. I then want to move into like identifying a independent versus dependent variable. And then I want to do a lot of work on our domain and range pieces. Okay. So let's just talk about what domain and range is and know that here in a little bit, we'll do a lot of practice. So have you heard the terms domain and range before?
Not in math.
Not in math. Okay, I like that. Not in math. Okay, so the domain is referring to all of the x values of a relation. Raise your hand. And the range, yes, is all the y values. Okay, so we're going to spend some time here soon looking at what if we have a list of ordered pairs? What if we have a mapping? What if we have a graph? All those sorts of things. How do we notate our domain and range? Those sorts of things. Okay. But what we are going to do is we're going to pick out the x's versus the y's. Okay. Now, our independent versus dependent variable. This is maybe something you've talked about in math before. Okay. So this is when we're talking about an equation with 2 variables. Okay, our independent variable, that's going to be our inputs. Okay, we like to think of those as our x values. Okay, the independent variable are what we are plugging into an equation or a relation. Okay, where the dependent variable, okay, like if your parents have health insurance, you're considered a dependent because you depend on them to have the insurance for you. Okay. A dependent variable is depending on something else to get its value. Okay. So these are going to be our outputs. And these depend on the inputs to get the value. Okay. And I'll give you an example. So I have the equation y equals 2x plus 3. So I'm going to pick x values to plug in for my inputs. Now, I can choose anything to be x and plug it in, but the y value depends on x in order to get the value. I'm going to plug in a number for x to figure out y. I'm going to plug in a number for x to figure out y. So x is independent. I can just put anything in for x, but y depends on that number getting plugged in for x. It's going to change based on that variable. Okay, it relies on what we plug in for x. Okay, so if you turn the page, we're going to look at this number 7. Okay, and I know we're going to talk about domain and range here in a little bit. Okay, so we'll come back to this example. But, well, we can probably still talk about it, actually. Y equals 12x. Y is the number of pages a computer can print in X minutes. We need to identify the dependent and independent variable. Okay, so which variable relies on the other? Why? The number of pages. Okay. X minutes is our independent.
What is it? 12, 6, 4, 3.
We're not there yet. X, the number of minutes, is our independent variable, where Y, the number of pages, is our dependent variable. Okay, because the number of minutes will affect how many pages get printed. X is affecting Y, so Y is the dependent variable. Okay, now let's interpret what we know just as a baseline about domain and range. I told you that domain was like our inputs and range was our outputs. So if I'm telling you that these are the 4 inputs, how do we get the outputs? Well, here is our relation right here. Here's our function. Okay, so if our domain value is 1, what are we going to plug that in for? X. Y equals. Okay, so our range will be 12. What about when X is 2?
6.
That's it.
4.
We're plugging into here. It's going to be 24. When we plug 3 in for X, what are we going to get?
36.
36. And then 4?
48.
48. That's going to be our range. Oh, yeah. Okay, so I have one of those like little foldable things. Okay, so you're gonna get this, and I want you to fold it like a book, where the very back page is gonna be the blank part. Everyone going? Okay, so you're gonna fold it to where the back page is the blank page. So take it like this, everyone look at me. And you're gonna fold it like this, so that this is the front and that's the back. Fold it like a book, and that blank page that you see, like, is the back. So fold it like that, yes. Okay, so this is what we're gonna use to take notes on. Now, this continuous versus discrete, this is something that's actually on the agenda for tomorrow, but we're gonna get just a jump start on it because it's going to kind of make finding our domain and range a little different. Okay, so how many ordered pairs are in this picture right here? 6. There's 6 of them. How many are in this one? Guys, there's a point right here. There's a point right here. There's a point right here. There's a point right. Anywhere you see black, we can put a point. And do you see how there's this arrow here? It's just going to keep going and going and going and going and going. Okay. So what I want you to understand is that a discrete relation is going to have what I consider a finite number of ordered pairs. Okay. We can like actually count them. Whereas a continuous relation is going to have an infinite number of points. Okay. And we're going to be able to like connect them. Like, do you see how we like can like put our pencil on here and not move it?
Yeah.
Whereas like from here to here to here, I have to pick my pencil up. But the line's not really there because there aren't coordinates in between. Okay, I get what you're saying, but the dots aren't connected, so we consider it discrete.
Why is it infinite and not infinite?
I don't know, because the English language is confusing, Elliot. So confusing, okay? So this is what's going to happen. When I ask you to identify the domain and range, you are literally going to list off the X's and the Y's. So when we have a discrete relation, we are going to literally just pick the X's out and pick the Y's out. So first of all, do you see these like squiggly braces? That's saying like, hey, this is a group. All right. So if I look at this relation and I look at all of the X's, I'm going to write that my domain is -2, -1, 9, and 10. Do you see what I did there? How I like numbers in order. Yeah. Kind of obnoxious. Okay. Then if I want my range, I'm going to look at my Y values. Okay, so my Y values are 1, 5, and 6. Sometimes when we have a discrete relation, our domain and range will have a different amount of numbers because sometimes we have some repeats. That's totally fine. There is no need for you to write down 1, 2 times in our range. You just have to write it once. Okay, are you okay with that?
Yeah.
Less work, right?
Yeah.
Yeah. Okay. Reagan, is this a function? It is. All of our X's have only one Y. The X's never repeat. Okay. All right. So how about you take this number 2? How about you write its domain for me, please? And range. And number 2, write the domain and range. Preston, what do you have for your domain? 3, 4, 5. Notice how he just wrote 3 once. He wrote 4 once. Okay. We don't need to repeat. Okay. Nirvan, what's the range? Okay. So what I'm going to do, Nirvan, I'm going to go ahead and put those in order. So I'm going to start with -3, then -1, then 0, then 2, then 4. Are you okay with that? Okay. Colin, is this a function? Why not?
Because 3 and 4 both have 2 on the
X equals 3 and X equals 4 both have 2 different outputs, so this is not going to be a function. You're going to be so good at identifying functions by the end of this week. All right, so now let's look at this mapping for number 3. Okay. This is like the best because they're already in order for you. Okay. Our domain is 1, 2, 3. Our range is 3, 7, 8. Too easy? Okay, okay. Amelia, is this a function? You betcha. Okay. The best way to tell from a mapping is that every X only has one arrow coming out of it. Okay. If an X value has more than one arrow, then that means it's being mapped to 2 outputs, and that's not okay. Okay. All right, you do number 4 for me. Do number 4 and make sure you and your elbow partner agree about it, okay?
4, 8, 6, 10.
Okay, so you're all working ahead of me and I'm boring you? Is that what's happening right now? Okay. All right, Carter, what's my domain? Okay. Estelle, what's my range? Okay, everybody, is this a function?
No.
No.
Yeah.
Okay. Okay, X equals 4 has 2 different Y values. So we do not have a function. All right, let's open this book up. Okay. Now, here's a good piece of advice for you. When we are looking at the domain, we need to scan from left to right to collect the X values. When we are looking at the range, we want to go from bottom to top to collect the Y values. Okay. So when we are looking at our domain, we are scanning from left to right. Here's the left, and I'm going to go to the right. Tell me when we see one.
I see one. Beep.
What's the X value?
-4.
That's not necessary. -4. Okay, my next X value? -1. My next X value is 2, and my next X value is 4. Okay. Our range, we're gonna go from bottom to top. So my very lowest coordinate has a Y value of -3. And then we keep going up here to 0. Then I have a Y value of 1. Then I have a Y value of 2. And then I have a Y value of 3. Avery, is this a function?
No.
What does it fail? Fails the vertical line test. So here's your reminder, and we already talked about the vertical line test today, but if a vertical line at any point, so I want you to look at this graph right here. If I draw a vertical line here, it's fine. Wait for it, it's coming. There, it's fine, okay? But if I draw a vertical line here, it's not fine, okay? So it just has to happen one time for it to fail and not be a function anymore, okay? How about you try number 6? So I have fostered before for that. Group. So I. Gavin, what's our domain?
-2,
Yep.
0, 1, 3.
Awesome. Our range, Andrew, what's our range?
-2, 1, and 4.
Awesome. Jaya, is this a function? Yeah. Passes the vertical line test. And anytime we have a graph, I want you to use the vertical line test as your reason. Okay. So let's skip over 7. Some of you already did it anyway, but I don't think we need to spend the time on it. So let's go ahead and go to the next page. Okay. When we had our discrete relations, we just like listed the numbers of our domain and range. Okay. But when we have a continuous relation, so notice how we have an infinite number of coordinates, okay, we're going to actually use some inequality signs. Okay. So our domain, like I'm going to go ahead and just like highlight this guy. Notice how I only have x values from 1 and then to the right. Do you see how that happens?
Yeah.
So we can say that our domain is x is greater than or equal to 1 because I have coordinates at x equals 1 and only to the right of them. Okay. Maybe it would help for you to like draw really lightly, like, oh, it's not going past this part right here. We're only to the right of it, so 1 and above. Okay. Now notice how, since these have arrows, this is going to keep going and this is going to keep going. So when we scan from top to bottom, we're always going to have that orange to deal with, right? Because this is going to go on forever. This is going to go on forever. So when we scan from bottom to top, we're always going to have y values. So we are going to write this really weird R, and it means all real numbers. Have you seen that before? Okay. Anytime you have all real numbers, like you go all the way to the left, all the way to the right, all real numbers, we're going to write this double back R. I don't know what you want to call it. It has like 2 backs, right? Okay. So for the remainder of class, we're going to work on these continuous graphs and looking at domain and range. Okay. Oh, but before we do, is this orange guy a function? No, it's going to fail the vertical line test. Oh, how sad. Okay. So let's look at number 1. When we go from left to right, is there going to be any time where we don't encounter graph? Okay, because even if I go all the way over here at like -10, this guy's gonna keep going and it's gonna be like somewhere up here, right?
Yeah.
Okay, and if I keep going to the right, I mean, I'm gonna have x's that go all the way, all the time. So our domain, we're gonna consider our domain to be all real numbers. Okay, however, when we scan from bottom to top, notice how I have nothing down here. Yay, worksheets. Thank you. Not for you. Oh, now it's better. Okay. So notice how at this point and above, I have y values. So I have nothing down here, but starting at, is this -3? We have something, and then I'll always have y values up here. So we're going to describe this as y is greater than or equal to -3. Yes, is this a function?
Yeah.
Yeah, it is. It passes that vertical line test. We're good. All right, let's talk about the domain and range of this guy. Okay, so from left to right. Are there places where I don't have anything? Yeah, I have nothing. I have nothing until I get to here, right? Okay, and then is it gonna keep going? This arrow means it's gonna keep going. So right here, I have X values and to the right of it. Okay, well, what value is this? Okay, so -2, and do we get bigger with them? So X is greater than or equal to -2. Yes.
Is there ever gonna be a scenario where X or Y is less than the number?
Yep. Give me one moment and we'll get to number 3. Okay, right? Okay, how about our range? Do we have things down here? Yes, okay. But then when we go to the top, they stop. Where do they stop at? 3. And are they bigger or smaller than 3? Smaller. So we're going to say that y is less than or equal to. Well, do you notice how all of these y values are numbers? Like if I look at this y value, they're all underneath of 3. So all of the y values of these coordinates are smaller than 3. Like this y coordinate is 0 and this y coordinate is -2. Are you with me, Estelle? Okay. So since we're below, we're going to be less. If we are above, we're going to be more. Okay. Is this a function?
Yeah.
You betcha. Okay. I'm going to go backwards. Is this a function?
No.
No.
No, it fails the vertical line test. Okay. Yes, but you don't need to worry about it until algebra 2. Okay. All right, our domain. We're going to go from left to right. Do I have things? Oh, I don't have anything on anymore, do I? So from here, what's the X value? 2. Okay, so from here, the X value is 2. And are these X's, they're to the left of 2, correct? Which means, are they bigger or smaller? Okay, so X is less than or equal to 2. Okay, now how about our range? Please keep in mind that this graph is going to keep going. One's going up and one's going down. So from bottom to top, is there ever going to be a place where we don't have? So our range is all real numbers because that thing's just going to keep going. How about you try number 6 for me? Try number 6. Number 6 has a similar shape than one that we talked about. Just try number 6. Try number 6. I will give you a hint that one of them is all real numbers and one of them is not. Nirvan, which one is all real numbers, the domain or the range? Yeah, very good. If we go from left to right, we're always going to have a piece that we can find on the graph. But when we go down to up, oh my gosh, look at all this empty space up here. Okay, so how would we describe the range? Y is less than or equal to -2. Okay. This is kind of weird, right? Okay. So this is what you're gonna do. You're gonna have an assignment for me. It's gonna come from the same book page as yesterday, but I will make a new post for today with the video. Okay, if you start to do your homework before 3:10, why that would happen, I don't know. If you start to do your homework before 3:10, you'll have to go to yesterday's post because I'm not gonna get this posted until about 3:10. Okay,